All right, boys and girls, welcome back to the drive-through. I'd like to give a shout-out to my lovely wife, Lisa, who is out of my league. Okay, the fundamental theorem of algebra. This seems so important, yet it is such a letdown, okay? If you'd like to copy down my simple version of this theorem, then pause the video, but here it is. It just states that the total number of roots will always equal the highest power of the leading exponent, okay? So, find the number of complex roots. Number one, since this is in standard form because it's in highest to lowest, and since that number is a 6, there are 6 roots. Number two, it doesn't matter that this is negative. That number is a 3, That number is a 3, and the answer is 3 roots. So I'll spare you guys from doing 3, 4, 5, and 6. You can do that on your own. But what I would like to do is explain a little bit more about real and imaginary. Okay? And to do that, we're going to use our graphing calculator. So, I'm going to turn my graphing calculator on, and we're going to type in negative 4x cubed excuse me real quick. I can't see that. Okay. Plus (2x squared) minus x plus 5. I'm going to hit enter, okay? Now we're going to graph it. We're expecting this thing to hit the graph at 3 places, but it doesn't. It only hits the graph at 1 place, so maybe your instincts would be to zoom out. Still, you can see that it's only going to touch it in 1 place. So I'll go back to my standard view. Okay, so then what's the situation? Well, what that means, and this is going to be important for us, is that, and this is not what's being asked in the first set of questions, okay? But now I know, since it hits the axis here, one of these roots is real. And then, therefore, since there were 3 total, 2 of them are imaginary. And that is essentially what we're doing in today's lesson. So, now what I'd like to do is, let's see, go to the next page. And go ahead and flip your worksheets over to the back. And let's take a look at number 8 and 9. I'm sorry, this isn't the back. Look down. Let's take a look at number 8 and 9, okay? So, the directions say, find all the zeros of each function, then use your graphing calculator to find the rational roots, then use synthetic division and factoring to find the remaining solutions. Okay? So what we want to do here is, well, we're just going to go through this nice and slow. So we'll type it in our calculator. Y equals x to the 4th minus 4x cubed plus 7x squared minus 16x plus 12. Now, before I graph it, I expect to have 4 real solutions to this. Okay? Let me zoom out. So hit zoom, 3, enter. And so we can see I'm going to zoom back in. Alright, so we can see two of them. And it looked like there's only two that we can find out. By just taking a close look, we can see that one is at x equals 1, and one is at x equals 3. Okay, so we know right off the bat and that two of our zeros are 3 and 1. So now we know our other two zeros must be imaginary. So how in the heck are we going to find out our imaginary roots? Well, I got bad news for you. You cannot use your graphing calculator. So we've got to use some synthetic division to get this thing from x to the 4th down to something we can work with. Okay, so here's what we do. We do synthetic division. 1 goes into 1x to the 4th minus 4, 7, I don't need a plus there, 7, a negative 16, and a positive 12. I bring down the 1, I bring down the 1 and I multiply it. Now I'll know I should definitely, these are definitely roots. So I should definitely get a remainder of 0 here, okay? If I don't get a 0 here, I've made a mistake somewhere. So 1 times 1 is 1. We multiply, then add. We multiply, then we add. We multiply, then we add. Excellent. Perfect, okay? So now what we are left with is x cubed minus 3x squared plus 4x minus 12. What we want to do is take that one, and I just wrote that down so you would understand what we have. With space being considered here, I'm going to erase that now, because what we want to do is take that function, and let's divide that by our other one. Okay? So we're essentially dividing out what we already know to be answers. So, bring down the 1, multiply, add. Multiply, add. Multiply. Excellent. So what this is x squared plus 0x plus 4. Okay, so now we are left with something that we can factor. X squared plus 4 equals 0. Well, we don't even really have to factor this one, because what you could do is just say x squared equals, actually, hold on, let me just tell you how I think you should do this. Let's go backwards. Let's just always use the quadratic formula, okay? So, x equals minus b plus or minus big square root of b squared minus 4ac all over 2a. This is, once again, where you'd really love to have that program that Caitlin showed you. If you don't know what that is, just Google quadratic formula program for graphing calculator. It'll come into big handy now, again. So x is equal to minus 0 plus or minus big square root of 0 squared minus 4 times 1 times 4 all over 2. Yep. So look what you get. You get plus or minus radical 16 over 2, which is equal, sorry, it's a negative 16. So that is plus or minus 4i over 2, which is plus or minus 2i. And notice, those are your final two roots, or your zeros. So, your zeros are 1 and 3, and then 2i and negative 2i. And remember from yesterday's that if 2i is an answer, then its conjugate will also always be an answer. Okay? So, Let me now do that same thing over again for number 9, okay? Let me repeat this process, but I'm going to give you some steps. So what do we do? Step 1, graph it and find the zeros. These are your reals. Step 2, divide, use synthetic division to divide out the real zeros. Step 3, use the quadratic formula to find your imaginary zeros. That'd be a good name for a band, Imaginary Zeros, I think. Maybe not. Alright, here we go. So, let's pop it in our calculator. Y equals x cubed plus x squared plus 16x plus 16. Graph it. I hope it hits 3 times. It doesn't. Let me zoom out just in case. It definitely does it. So I'll zoom back in. Remember, in our standard window, all of these dashes are 1 unit. So that means that -1 is our only real solution. Okay? So, we found our zero real is -1. Now we need to find our imaginary reals. Okay, so put -1 here. Write down 1, 1, 16, 16. Bring down the first one, multiply. You'll know you're getting it right if you get a 0 there. Add. Multiply. Remember, -1 times 0 is 0. Add. Multiply. Excellent. So this is x squared plus 0x plus 16. Now we got to do minus b, so -0 plus or minus big square root of b squared minus 4 times a times c all over 2a, so 2 times 1. So you get the square root of -64 over 2, which is plus or minus 8i over 2. So our other answers are 4i or -4i. And that is the process you're using. It's going to be a tough day. Okay? You guys work through it, and then we'll review all of this tomorrow, and we'll also review it with Math Excel on Thursday. Thanks for tuning in. Boom!